This is the video that we made after we changed out the 3.5 ton system. As you see, the 16-inch return on the existing system wasn't enough to give proper airflow to the downstairs of the house. So we added the second return into the system to get proper airflow across the air conditioning and furnace at the new job. We also put a perfect fit air filter in to help with cleaning up the dust, the dust with inside the house. We did a sheet metal return with R8 duct wrap on the back. Anytime that anything's in the airstream, you have a friction rate across it. The reason why we do sheet metal with insulation wrapped on the outside is we don't have to deal with that friction rate like we do when we have liners installed in them. Also on this furnace here that we put in, we put a surge protector because we get such erratic, we get 2 or 3 calls a year because of power issues at the house. So we try to install the surge protectors at the equipment, because most of your equipment now has electronic boards in them, and they have electronic motors in them that that the manufacturers install in them to make the system work right and get the efficiency out of it. What we do is we match everything as per the manufacturer and engineers requirements. We try not to mix and match the equipment, because you can't get a rating on the equipment when it's like that. Also on this job, we put access doors in so that we can come back and clean the evaporator easy. And also we put UV lights in that help keep the algae and microbiology growth down inside the system. Also on this job, what we did is we do the sheet metal transition from the furnace to the evaporator coil. And the reason why we do this is because we've seen on jobs in Houston that they've used fiberglass ductboard to do this transition. We know that this doesn't last, and what we try to do is put in a system that will last and get the customer the best return on investment. Also in the Houston market and the Cypress market, we find that a lot of the homes that are being put in together today with the air conditioning is that they mastic all of this in. We don't do this because this door has to be accessed for service, and this is why we don't mastic it in, because if you do this, then you have to dig that stuff off of it, and it doesn't allow it to seal back right back to the evaporator coil. And also on the front of the supply ducts, we put the sheet metal with it wrapped on the outside because of the friction rate that we believe affects the airflow in the house. Also on this, the flex ducts that are connected to it, we add dampers in it, because sometimes we'll get houses that have a room in them that's not cooling right. And the way that we balance the system is when we come back in, we put sheet metal, we duct wrap it, and we also put the damper in to control the airflow into this duct, which feeds the house. Another thing that we do that makes our jobs less problems to them is we slope the drain line a little bit better than what the code requires, because the algicide and the slime that grows in that comes off of the evaporator section will build up in the line. If you slope it better, it doesn't give it a chance to build up in the line. We put an access in it to pour chemicals in it, which is BBJ, environmental solutions, not bleach. And this allows this line to stay nice and clean during service when we come back to service this equipment. We also put the emergency drain line under the evaporator, and we also run the line to back to the outside of the house, as well as putting a float switch in it, because the outside line could get some kind of insect in it and plug up. And so we put a float switch in it that will shut the system down and allow the customer to not have overflow issues and drywall damage. We also, on 410A, what we do is we insulate the liquid line, because we're finding that using 410A that the attic's temperatures will get up to in excess of over 100 something degrees. And why we insulate the liquid line is because this temperature will allow that line to allow the liquid to flash if there's a long run between here and the condensing unit, or a long run from the attic where this line comes into the attic and the line runs across the attic. And so we insulate that line, and it doesn't allow the flashing to take place, which cuts down on the capacity issues that other companies have experienced with it, and we've come in and resolved those issues that these customers have had with improper installation. We really try our best to put this equipment in to give the maximum return on investment. We're not newcomers to this business. We've done thousands of these change outs, and this works the best for the customer. Air conditioning is the most expensive appliance in your house. If it's not installed incorrectly and it's not measured right, you'll see this. As you've seen on the video, the previous video, you've seen where the static pressure on the system, that's the resistance across this furnace, was at a 1.0 static pressure. The equipment manufacturers of that equipment only wanted a 0.5 static pressure drop across the whole system. And when we examined it and we measured it, we found that the return was the issue, where it was not getting enough airflow back across the system. Airflow across these units is the most crucial thing that you can do. Without proper airflow, the charge can't be right, the system runs inefficiently. And with the companies that are out there that are measuring efficiency standards, they're finding that 40% of the equipment does not meet the rated efficiency, and that they all have 70% of them have airflow issues. This is what we do that makes that you're ensuring you that we put in the system, we measure it, make sure that it's running to the maximum efficiency. And I hope that this video helps you out in choosing the right contractor to put in your new air conditioning unit. Thank you.